Hi everyone! Now if you've seen any of my videos before, you know that what I normally do is a math problem, or sometimes a physics problem, or maybe a math puzzle. But today I'm going to do something a little bit different. Now there's this video that I saw on Facebook, and I'll pull it up right now. And what it purports to show is, on the left, a teacher is teaching a method of doing multiplication that you maybe haven't seen before called the grid method. And on the right, there's an adult using the same algorithm that you learned back in school if you went to school 20 or 30 or 40 years ago. And the idea behind the video is the adult has enough time to finish doing the math problem the old-fashioned way, and then make himself a cup of coffee and finish it before the teacher has finished this newfangled method. The Common Core must therefore be stupid, because an adult can finish this problem so much faster using the old method. Why are we learning the new methods? Well, what I'm going to show today is that that's a dumb argument. And I'll show you why Common Core, or the new math, or whatever you want to call it, why these new different methods are really very powerful ways to teach your children math, and what Common Core is really trying to do. So, with no further ado, we'll turn off that video and get into it. So first, a little terminology. The method on the right, the old one that we've all known and loved from years and years and years ago, that's called the standard algorithm. And the method on the left, we're going to call that the grid method. And I'm going to go through both methods really quick, although I know you probably know how to multiply numbers, just to point out a few things about each. Okay, so to multiply 47 by 23 using the standard algorithm, first thing I'm going to do is I'm going to multiply 3 times 7 and I get 21. Now rather than write down 21, I just write down a 1 and then I put a little 2 above the 4. You ever stop to think, why do we do that? Let's move on. We'll come back to that in a second. Alright, so the next I multiply 3 times that 4, I get 12, and then I add that little 2 in there, and I get 14, and I write that down, 141. Now, I need to scratch out that 2, and I need to write a little 0 down beneath the 1 there. And again, any idea why we do that? Whatever, we'll come back to that. So we scratch out the 2, we write a 0 down there, and now we're ready to move on and do some more math. 2 times 7, that's 14. We put down a 4, and for some reason we don't put the 1 next to it, we put the 1 way up there. Again, imagine you're a third grader. Why do you suppose we do that? We'll get back to it. Alright, 2 times 4, that's 8, plus 1 is 9. We write down the 9. At least that makes sense. And now we add those two numbers together. So, 1 plus 0, that's 1. 4 plus 4, that's 8. And 1 plus 9, that's 10. We come up with our final answer, 1081. 47 times 23 equals 1081. Now I'm going to contrast that with the grid method. So in the grid method, over on the left side of your screen, the first thing we do is we break the number up into its digits. So 47, that's really 40 plus 7. 23, that's really 20 plus 3. And by the way, if you had a 3-digit number or a 4-digit number, you could do the same thing. It would just take a bigger grid. Now we multiply each part by each part. And what I mean by that, for example, is 40 times 20, that's 800. We write that right there. 7 times 20, that's 140. 40 times 3, that's 120. And 7 times 3, that's 21. And now to get our answer, we just add up all the parts. So 47 times 23, that's going to be 800 plus 140 plus 120 plus 21. Well, 0 plus 0 plus 0 plus 1, well, that's 1. 4 plus 2 plus 2, that's 8. And 8 plus 1 plus 1, that's 10. The answer, 1081, just like before, of course. Why do people get so upset over Common Core? One of the arguments that they make is just plain false. The argument is that Common Core no longer teaches the standard algorithms. And this is just not true. In fact, this isn't an argument. This is a myth. In fact, Common Core makes the standard algorithms mandatory. So the algorithm for multiplication that we just went through, the standard algorithm for multiplication, According to Common Core, students still have to learn that. Don't believe me? Here's the Common Core standards, and you can get them right off their website. I've got the link right there, www.corestandards.org, and then just search math, standard, and algorithm, and this will pop up. So in grade 4, it says students must be able to fluently add and subtract multi-digit whole numbers using the standard algorithm. By grade 5, they must be able to fluently multiply multi-digit whole numbers using the standard algorithm. And by grade 6, they have to be able to do addition, subtraction, multiplication, and division of multi-digit decimals, all using the standard algorithm for each operation. So the idea that Common Core replaces the standard algorithms that you learned if you were a student, say, 30 or 40 years ago, that's just false. Common Core doesn't replace those. It still teaches those. What Common Core does do, however, is teach some additional methods. So maybe you say, well, why bother with the additional methods? The standard algorithm, isn't that faster and more accurate? And therefore, isn't that the only one we should be teaching? After all, that's what the video tried to show. Why bother learning these weird ways to multiply numbers when the old-fashioned way is faster? Well, the answer is the standard algorithm is faster, but is speed really the most important thing students need to learn? It's not. Number sense is. If we really wanted to teach students the fastest way to multiply numbers, let me show you what that is. The fastest and most accurate algorithm is pull up a calculator and multiply 47 times 23 using a computer. It's going to be thousands of times faster than any human being and also more accurate. Now, the reason we use the grid method is because the standard algorithm has some problems. Remember when I was doing the standard algorithm before? There were a couple of steps in that algorithm that just don't really make sense. For example, why did we write a 0 right there? Why did we put a 2 up there? And then why did we have to cross it out? Why did we have to put that 1 right there? The first step we did was 3 times 7 equals 21. Why did we put down just the 1 and put the 2 up on top? Now, most of the time, your teachers in schools are going to provide the same answer you're probably thinking of right now, because that's just the way we do it. But let me contrast that with the grid method. When we use the grid method, you don't have any of these conundrums. You don't have any of these questions. It's pretty obvious where all the parts come from. In the grid method, we emphasize that 47 is really 40 plus 7 and 23 is really 20 plus 3. Therefore, there's no mystery where that 800 came from. That's the 40 of 47 times the 20 of 23. There's no mystery where that 140 came from either. That's the 7 of 47 times the 20 of 23. And so on and so forth for all of the parts. The grid method is actually a much more intuitive method for teaching students who have never seen multiplication of multi-digit numbers before why it works. The standard algorithm hides those details. And really, it becomes just a recipe that you follow, rather than something that you actually have to understand and think about. All right, well, here's an argument you'll sometimes hear. The grid method, why teach a method that students are going to learn once and then probably never use again? Well, we've already covered one reason why to do that is because it helps build number sense. By breaking numbers into their parts and then putting them back together again, you can find easier ways to solve the problem. For example, could you multiply in your head 35 times 12? Well, that's a little difficult, but if you think to yourself, hey, 35 times 12, that's the same as 35 times 10 plus 2. 35 times 10, that's 350. 35 times 2, that's 70. 350 plus 70 is 420. You can do that whole problem in your head without ever writing it down on a piece of paper. And that kind of number fluency is a good thing for students to learn. And it's emphasized by the grid method in a way that it's not emphasized by in the standard algorithm. But let's get back to the original. Why teach a method that students will probably never use again? Well, the fact is they can use it again. It's far more applicable later in mathematics than the standard algorithm is. Don't believe me? Well, check this out. So we've already done simple two-digit math. 47 times 23, we've done that problem using the grid method, and we see that it works, and that's something that students might learn in grades 3 or 4 or 5. But eventually, they're going to work on harder numbers. Eventually, they're going to work on mixed numbers, numbers and fractions. And there's no way to do 4.5 times 25 1/4 using the standard algorithm unless you first convert 1/2 and 1/4 into decimals. That's the only way to do it using the standard algorithm. But using the grid method, you can do it directly. How? Well, just like this. Notice that 4.5 is the same as 4 plus 1/2. And 25 1/4 is the same as 25 plus 1/4. Now, we can just multiply across, the same as we did before. 4 times 25, that's 100. 25 times 1/2, that's 12.5. 4 times 1/4, that's 1. And 1/2 times 1/4, that's 1/8. And now to get the answer, we just add up the parts. I'll do the whole numbers first. 100 plus 12 is 112, plus 1 is 113. Plus the 1/2 from 12.5 is 113.5. And now all I have to do is add 1/8 to 113.5. Well, 1/2, that's the same as 4/8. 4/8 plus 1/8 is 5/8. And the total answer is 113 5/8. Yeah, we can use the grid method to do mixed numbers, but we couldn't use the standard algorithm. Hey, what about polynomials? Can we use the grid method for those? Well, actually we can. Across the top, I'm going to write 3x squared and 2y cubed. Down the left side, I'm going to write 6x and 12y squared. And now I'm going to multiply across. 3x squared times 6x, that's 18x cubed. 2y cubed times 6x, that's 12xy cubed. 3x squared times 12y squared, that's 36x squared y squared. And 2y cubed times 12y squared, why, that's 24y to the 5th. And now I just add up the parts, and I get 3x squared plus 2y cubed times 6x plus 12y squared equals 18x cubed plus 12xy cubed plus 36x squared y squared plus 24y to the 5th. Certainly can't do that with the standard algorithm. What about complex numbers? Can I do those? Well, yeah, I can. I write them in my grid, same as before. I multiply across, same as before. And now the only difference is I have to note that that negative 6i squared in the bottom right corner, well, I squared is negative 1, so that really just becomes positive 6. And I add up everything that's there. 20 plus 6 is 26. 18i plus negative 15i is negative 7i. And I get my answer. 5 plus 2i times 4 minus 3i, well, that's 26 minus 7i. Sure enough, the grid method works with complex numbers also. So in summary, Common Core still teaches the standard algorithm because it's a fast and efficient way to multiply multi-digit numbers. But it uses these other methods, like the grid method, and there are some others, because they're a better way to teach math. These other methods have lots of benefits. First of all, they're easier to explain. There's no mystery. You don't have to wonder, hey, where did that 0 come from? Why am I carrying the 2 instead of just writing it next to the 1 in 21? It makes more intuitive sense to new students. They can be made applicable to higher mathematics in a way that the standard algorithms don't. The standard algorithms basically instill in students the idea that math is just a recipe. You basically follow blindly a recipe and you get the right answer. Well, that's not really what math is. Math requires thought. Math requires thinking. Math requires something called number sense. And all of these Common Core methods are designed to help build number sense. Alright, I hope you liked the video. If you do, click subscribe. If you want to comment below, go ahead and click and comment as you will. And please check out some of my other videos, which are more math puzzles and physics puzzles. And hope to see you all again.